Hello and welcome to lesson 1 of this Functional Skills Maths Level 1 course with National Tutors. My name's Sarah and I will be your tutor for the duration of this course. So before we begin, I'd like to draw your attention to some accompanying revision books that I would highly recommend. They'll complement the course well. They're going to cover all the topics we're going to be looking at in each of our videos, along with allowing you to take 10-minute tests to make sure that you're keeping up to date with your knowledge, and revision cards that will come in handy to help you prepare for your eventual exam. So today we are looking at numbers. More specifically, we're going to be recognizing and learning how to use whole numbers, decimals, and negative numbers. We will be learning how to understand place value, how to round numbers and use said rounding for estimation, and how to apply number skills to solve everyday problems. So first things first, how do we identify a whole number? So whole numbers are integers that do not contain a decimal or present themselves as a fraction. So as long as your numbers look like those on the left-hand side, no decimals or fractions in sight, that is indeed a whole number. Now we will be looking at decimals and whole numbers in more detail later on today, but we will be looking at whole numbers first. So, place value. Let's first of all look at the place value chart on the left here. It goes as high as millions and as low as thousandths. I will explain what those last three on the end mean in just a second. But first of all, let's have a look here. So if I were, for example, to put a 1, 2, 3 here, then that would mean 3,210. Sorry, I forgot the 0. Let's try that again. 3,210. I have 3,000s, 200s, 110, and 0 ones. Now I can never have more than 9 in any of my columns. The reason being, if I have more than 9 ones, well, that increases to a 10. So that would jump over to my next column. So I'd end up with 110 and then 0 ones. If I had 9 tens and 0 ones, that's obviously 90. But if I had 9 tens and 9 ones, I have 99. Any more than that, it's going to jump across to my hundreds column, and so on and so forth. So you can see that we can't ever have more than a number 9 in any of our columns. So if I may give you a couple of examples, if I were to put a 7 here, that's worth 7 million. If I were to put an 8 here, that would not be worth 8,000, but 80,000, because it's 8 lots of 10,000. If I were to put a 5 here, that's worth 500,000. So please feel free to pause the video and have a play with this chart, perhaps rewrite it out on a piece of paper and see what numbers you can create. Now, as I said, let's address these three more unusual numbers at the end here. So you can see here we have what is a decimal point. So any number lower than 0 can be presented in one of two ways. Either as a decimal point, if it is still positive, it can be presented as a decimal point, or we can go into negatives. Now we can have negative decimal points as well, but for the sake of this exercise, we're going to stay with positive numbers. So if I have a 1 and then a 5, that number is 1.5, which is the same as 1 and a half. Now we'll be going into more detail over the next few sessions with decimals and fractions, so you will see some more examples of those in lessons to come. Now, what if I had a 0 here and then a 2 and a 3? So I have 2/10 and 3/100, or 0.23. Now, as a fraction, that would be 23 over 100. Again, don't worry too much if that's not completely clear. We will be having lessons in the future about how we convert from a decimal to a fraction. And finally here we have thousandths. Now of course the place value for decimals does go further, but for today we're going to stop at thousandths. So for the final example I might have 2, 5, 7, 9, and that says 2.579, 9 thousandths, 7 hundredths, 5 tenths. So our whole numbers before the decimal point and hundreds, tenths, thousands, etc. afterwards. Now you can have a very large number. We might have 140.7, for example. We can have large numbers that are also decimals. That can happen as well. So let's now have a look at a couple of examples of addition and subtraction on the right hand side here. So we've got 1759 and 2432. Now I've chosen these numbers specifically because it involves a skill called carrying. So remember earlier when I said you can't have more than a 9 in any of these columns, otherwise it carries over to the next. Well, the same principle here applies. So if we were to add up this number, so first of all, a very important thing to remember is that we always start with the ones column and then we work our way up. If we were to start adding the thousands and then went to the hundreds and the tens and the ones subsequently, we may end up in a little bit of a muddle. So we always start at the ones column. So we can see here that if we add the 9 and the 2, we're going to end up with 11. Now, I can't, unfortunately, just put 11 in my ones column. What I need to do is think of 11 in terms of tens and ones. So 11 contains 1 10 and 1 1. And because this is my ones column, I would put a 1 there and I would carry a 1 to the next column into my tens. So if you would like to pause this video and write this calculation down and follow along with me, we will end up completing the calculation together. So once again, we're going to end up with 1 1 in our ones column and 1 10 in our tens column. So then next we're going to add the 5 and the 3, which is 8, but we mustn't forget the 1 that we carried over as well. So 8 plus the 1 means we're going to have a 9 in this column. So far we have a 1 in our column, a 1 carried over, which means we have a 9 in our tens column. So far we've made 91. Now let's go over to the hundreds column. We have a 7, add a 4. We end up with another 11. Now we know we can't have 11 in one square or in one column. So once again, just as we did with our ones, we're going to put a 1 in the hundreds column and carry across to the next column the other 1, or the 10. So far I have 1, a 9 and a 1, so 191. Let's move on to our last column, not forgetting that we've got a 1 carried across. So we've got a 1, a 2, plus the 1 that we carried across. So we're going to end up with 4,191 for our answer. If any of that confused you or you got a little bit lost, please feel free to rewind the video and watch it through again. One more example before we move on, this time of subtraction. And again, I've made some deliberate choices here to show you another skill that's really important here called borrowing. So, subtracting, again, starting with our ones column, really important here. 6 subtract 3 is quite straightforward, will give us 3. So 3 in our ones column. Now next we've got 1 take away 4. Now we're not going to be going into negative numbers with this exercise. We can't take 4 away from 1. There's too many on our second row. So what we have to do is we have to borrow from the next row. I'm going to cross out my 5 and turn it into a 4, taking the 1 I've subtracted and putting it next to the 1 in the tens column. Turning my calculation into 11 take away 4. 11 take away 4 leaves me with 7. So far I have 3 in my ones column and 7 in my tens column. Next, I have 5 take away 7. I've got the same problem again. I can't take 7 away from 5 because at the moment we're not going to be going into negative numbers. Now, I said 5 take away 7. I've already forgotten that actually we've already had to turn this into a 4. So I'm going to borrow from my 8. That's going to become a 7. And I've now got 14 take away 7. Let me go through that one more time. So we had to borrow from our 5 so that I could end up with 11 take away 4. So now I'm going to borrow from my 8. That becomes a 7. And I put my spare 10 next to my 4. So I end up with 14 take away 7. 14 take away 7 is 7. So that's now solved that problem. So far I have 7, 7, 3. 773. So let's look at the last column. Luckily this one's straightforward. 8 take away 6, but hang on. I'm forgetting that we already had to borrow 1 from this column. So actually now it's 7 take away 6. 7 take away 6 will leave us with 1. So our answer is 1,773. Did you get the answer right? Again, if you're at all confused or gotten a bit of a muddle there, please feel free to rewind the video and have another look. Okay, so now we are looking at rounding. Rounding is a way to simplify a number in order to estimate, which we'll look at in just a short while. Simplifying a number by calculating it to the nearest whole, so the nearest 1, the nearest 10, 100, etc. You can also round decimals, but we won't be looking at that today. That will be in a future lesson. So if I may put some examples on the screen. If I had, let's have a think. If I had the number 14 and I wanted to round it to the nearest 10, would I round it up or down? Now that's a really good question. To answer that, we're going to look on the left-hand side here. It's a really important rule we must follow when we're rounding numbers. If your number ends in the number 4 or smaller, we will always round down. If, however, your number ends in the number 5 or higher, we will always round up. So if I may give you the example of 14 again, 14 ends in the number 4, that's in my blue section, so I'm going to round down to 10. If, however, I had the number 16, that's in my yellow section, it ends with a 6, so I would round up to my nearest 10, which would be 20. Let's try another example. What if I had the number 5? Would I round up or would I round down? 5 is just on the cusp, but the rule is if it ends in a 5, we round up. So we would round the number 5 up to 10. Now, as I said earlier, you will be learning to round with decimals as well. Let's have a look at an example of a decimal then. So 4.3. The number ends in a 3. So we would round down to the nearest whole, which would be 4. Let's look at another example. What about 6.7? Our number ends in a 7, so we would round up to the nearest whole number, which would be 7. Let's try a bigger number now. What about 125? Now, if I was rounding to the nearest 10, I would round up to 130. However, if I was rounding to the nearest 100, I would round down to 100. Now, some of you might be thinking, but hang on, that number ends in a 5. You said that numbers that end in a 5 we would round up. Yes, I did. But now we're into larger numbers. There's something that changes just a little. When we're looking at a number like 125 or any number that's larger than 2 digits, the first number is what's going to be rounded. So 125, the 1 is what's going to be rounded. The second number, the second figure, is what's going to be called our decider. Our decider literally decides whether we are going to round up or down. So once again, 125. 2 is lower than 5, 20 is lower than 50, therefore it would round down to 100. So if I may illustrate a little bit more with another example, if I had 150 and I was thinking about the nearest 100, this number exactly halfway between 100 and 200. And because my second figure, my decider, is a 5, it would round up to 200. If I had the number 340, my second digit is 4, that's my decider, it's lower than 5, so I would round down to 300. Now, if I had the number 346 and I was rounding to the nearest 10, I would look at the 6. I'm rounding to the nearest 10, so this is going to be my affected figure. 6 is my decider. It's larger than 5, so I would round to 350. So it greatly depends on what you're rounding to. Sticking with the 300s, if I had 346.2, and I'm rounding to the nearest one whole, 346.2, this is my affected figure, 2 is my decider, it's lower than 5, so I would round down to 346. if I had 346.8 to the nearest whole, 6 is being affected, 8 is my decider, it's higher than 5, so I would round up to 347. So just with our place value, whatever you're rounding to, the nearest whole, if I had 7.6, the nearest whole, my whole number is 7, 6 is my decider, it's higher than 5, I would round up to 8. If I had the number just 7 and I wanted to round to the nearest 10, that's higher than 5, I would round it up to 10. If I had the number 71 and I was rounding to the nearest 100, I don't have any 100 to focus on, but 7 is my decider. It's higher than 5, so I would round to 100. If you have any more questions, please feel free to rewind the video and also check out the City and Guilds book at the end of this recording. Okay, so as I said, one of the main uses for rounding is estimation. So we're going to have a look at an example below. Estimation is a way of getting to an answer a bit more quickly if you want just a rough idea of what a calculation is going to equal. So as you can see, the original calculation here is 479 add 826. Now that's quite a tricky calculation to do. You can of course do it on paper, but if you're looking to get just a rough idea, estimation is the key. So the actual answer to the original calculation, if we just used column addition, our answer would be 1,305. Now, if we have a calculator or we've got the time to work it out manually, that's not a problem. But some questions in maths and indeed in your future exam will require you to demonstrate your estimation techniques. So, just as with rounding on the previous page, you can round to the nearest 10. So 7 is higher than 5, so 479 becomes 480. And then 826 to the nearest 10 becomes 830, because 6 is higher than 5. So 480 add 830 will give me an answer of 1,310 or 1,310. Now that's not very far away from our original answer of 1,305. That's actually very close indeed. And that is often the case with estimation. However, you could also round these numbers to the nearest 100. 4 is our affected number, 7 is our decider, it's higher than 5, so 479 becomes 500. And 8 is our affected number, 2 is lower than 5, so this time we would round down to 800. So then we have 500 add 800, and that is 1,300 exactly. So you can see that with our three answers, they're not too far apart, and how estimation can actually be a really valuable tool. It's often used in day-to-day life to get what's called a ballpark figure or a rough guide to a mathematical problem. So feel free to pause the video and give yourself another calculation to try with your rounding. Remember, if you're rounding to the nearest 10, you're looking at the tens column. That's going to be your affected number. Your 1 is your decider. 9 is higher than 5, so 79 becomes 80. And again here, focus on your tens. We've got a 2 in the tens column, but we've got a 6 in the ones column. 6 is our decider, so 26 rounds up to 30. And then once again, 479, if we want to round it up to the nearest 100. 4 is our affected number or affected integer. 7 is our decider. Our decider is higher than 5, so it rounds up to 500. And finally, 8 in the hundreds column. 2 is our decider. It's lower than 5, so we will round down to 800s. If you have any questions or wish to watch this again, please feel free to rewind it. And again, in the study books after the session, there will be more examples for you to practice. So now, as promised, we're going to be looking at negative numbers. Negative numbers are below 0. As I said at the beginning of the video, you can also have decimal places in the negatives, but we're going to be sticking with just whole numbers for today. Now, negative numbers happen when we are taking a larger number away from a smaller number. For example, 5 take away 7. And I'm going to be using this number line to demonstrate how we can work that out. So starting at 5, I'm going to take away 7. 1, 2, 3, 4, 5, 6, 7. Leaves us with negative 2, or sometimes called minus 2. Now, negatives can go as high as you like, really. We could have 13 take away 20. Now, the key to a question like this, you can work out how many it would take to get to 0. So if we're starting with 13, we count down to 13 to get to 0, and then work out how many extra we have. So 13 take away 20. To break it down a little further, if 13 will take us to 0, if I over here work out what 20 take away 13 is, I know that leaves me with 7. So once I've taken away my 13, I end up with 0. I will have 7 more to take away. So if I'm at 0 and I've still got 7 to take away, 1, 2, 3, 4, 5, 6, 7, that means 13 take away 20 equals negative 7. Now we can, of course, start with a negative number as well. What if we had negative 1 take away 8? Same process. Start at negative 1, 1, 2, 3, 4, 5, 6, 7, 8. So negative 1 take away 8 equals negative 9. So one more example then, I think. Let's start with the number 3. And we're going to take away 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have got the answer negative 7. Now, if you aren't fortunate enough to have a number line to help you, you can use that technique we used a couple of minutes ago. 3 take away 10. I know I'm going to need 3 to get to 0. So once I've counted back to 0, I'm going to have 7 left over, and 0 take away 7 equals negative 7. So therefore 3 take away 10 equals negative 7. Let's try a couple more now without the number line. A bit trickier this time. Let's have 21 take away 30. So let's work out how many I'll have left once I've counted down to 0. It will take me 21 to count down to 0. And once I have counted down to 0, I will have 9 left to count. So once I'm at 0, I'm going to take away that additional 9, and that leaves me with negative 9. So 21 take away 30 is negative 9. And of course, you can go into the hundreds or even the thousands. What if I had 110 take away, goodness gracious, I don't know, 122? I'd start with working out how many I'd have left once I got to 0. So 122 take away the 110 equals 12. So once I'm at 0, I still have 12 to take away that 12, and it equals minus 12. So 110 take away 122 equals negative 12. So please feel free to rewind the video, watch any of that again, and as I said before, take a look at the accompanying literature after the session for some more practice. So now I'd like you to pause the video and have a go at matching these 5 concepts to their correct definition. So can you find the whole number, the decimal, the negative number, the example of rounding, and the example of place value? So pause the video for as long as you need and see if you can match them correctly. All right, how did you get on? Let's have a look. So, first of all, the whole number. Well, I can see we've got a number of examples here, but the correct answer would be B. 89 is our whole number. So if you got that correct, well done. Our decimal. So I know what a decimal looks like. It looks pretty much like a full stop, but in the context of maths. So that means number 2 matches with D. 5.2 is our decimal in this example. Our negative number, I know that that's a number below 0. So there's always the little minus number that comes before it. So number 3, our negative number, is negative 11. Well done if you got it right. Second to last, rounding. An example of rounding here. I've got A and E left. I think out of those two, E is much more likely because I can see 59 is being rounded up to 60 because 5 is our affected number, 9 is our decider, 9 is higher than 5, so it's being rounded up to 60. And last one, that means that our place value must be A. The 5 in 4,598 is worth 500. So well done if you got 5 out of 5. Don't worry if you didn't. Everyone here is still learning. Please feel free to pause or re-watch that if you need to go over it again. And have a look in your exercise books after the lesson for some more examples. Okay, so now we're going to be looking at some practice questions. There's 8 in total. Pause the video for as long as you wish. I will be going through the answers one by one, so it's up to you whether you wish to complete a question and then check the answer, or complete them all and check them all at once. Entirely up to you. So first off, round 679 to the nearest 10. So it's very important that I know what I'm rounding to here. So 10 means I'm going to be focusing on my tens column. 7 is in my 10 column, which means 9 is my decider. 9 is higher than 5. So I'm going to be rounding my 7 to the next 10, which is going to be 8. So my answer is going to be 680. Number 2, round 231 to the nearest 100. So this time I'm going to be focusing on my hundreds column. I've got 2 in the hundreds column, which means the 3 in my tens column is my decider. 3 is lower than 5. Whoops. So 3 is lower than 5. So therefore, I'm going to be rounding down to 200. Okay, a place value question now. What is the value of the 5 in 3,851? 3,851. Now you can put your place value labels up here if it would help you. Thousands, hundreds, tens and ones. That's always a good useful tip if you find this a little bit tricky. I can see the 5 is in my tens column. So that means 5 times 10 or 5 lots of 10 is 50. So the 5 in this number is worth 50. Now, a bit trickier this time, what is the value of the 7 in 10.73? Now, this time our place value involves a decimal, and the number in question is the first after the decimal. So that means we're going into tenths, hundredths, and thousandths. I can see that 7 is the first number after the decimal, so that means it is a seventh. Or you could also write it as 7 tenths, 7 tenths. Or you could write it as 0.7. Any of those would be correct. So a seventh, 7 tenths, or 0.7. Any of those would be correct. Okay, negative numbers now. Which number is larger? -7 or -2? Now, at first glance, this could potentially be a tricky question. I'm going to draw a number line to help me. I'm going to put 0 up here, -10 down here. I know -5 will be in the middle here. I'm going to put it down here so I've got space. And I know that -7 will be about in the center here and -2 will be over here. Now, even though 0 is a very small number, I know that it is larger, than -10. So even though we know that +7 is bigger than +2, when we go into negative numbers, -7 is actually smaller than -2. Sometimes it helps to think of these as temperatures. If you think of a thermometer and we have +7 degrees and -7 degrees, -7 degrees is much colder than +7 degrees. So, which number is larger? The answer is -2, because -2 is closer to 0. Now, what about the next one? Which number is smaller, 2 or -5? Well, the same principle. Again, you can imagine your thermometer. We have 0 degrees here. So positive numbers go up, negative numbers go down. Our -5 is about here. And then this is a +2, so it's going to be up here. So we can see very easily that 2 is going to be larger than -5. So which number is smaller? The smaller number is -5, because on our thermometer it would be colder. 2 more to go. Well done if you've kept going. Use rounding to estimate the answer to 187 plus 366. Now there are a couple of acceptable answers here because the question doesn't actually state what it would like you to round your numbers to. So you could have chosen to round your numbers to the nearest 10. So in which case, if you did do that, 8 is in our tens column, so 7 is our decider. 7 is higher than 5, so that would become 190. If you were rounding 366 to the nearest 10 as well, 6 is in my 10 column, and then the 6 ones is my decider. Again, 6 is higher than 5, so that would become 370. So if you chose to round to the nearest 10, that would be 190 plus 370, which would give us a total of, let me write that out again quickly, 190 plus 370 would give me a total of 560. So if you got 560 for your answer after rounding to the nearest 10, spot on. If you chose to round to the nearest 100, that's also fine. Again, usually the question will state whether it wishes you to round to the nearest 10 or the nearest 100, but occasionally it won't, and you have to use your best judgment. So if you rounded to the nearest 100, I'll focus on my hundreds column first. So then 8 in my tens column is my decider, which is higher than 5, so I would round that to 200. If I was rounding 366 to the nearest 100, 3 is my affected integer, 6 is my decider, it's higher than 5, so I would round that to 400. So I would end up with 200 plus 400, which would give me an answer of 600. So whether you got the answer 560 or 600, both answers are acceptable because in this case, you had to use your best judgment for the estimation. And last but not least, round 896 to the nearest 10, then the nearest 100. Is there a difference between your two answers? We haven't come across a question like this before. So, first of all, to the nearest 10. Well, my 10 is already a 9, so we're pretty high up. And 6 is my decider. So I need to round 9 to the nearest, to the next 10. I'm going to be rounding up because 6 is higher than 5. But I can't go higher than 90 without rolling over to the hundreds column anyway. So even though I'm rounding just to the nearest 10, because my 10 has 9 in it, I have 9 tens or 90, and my decider is a 6 higher than 5, I'm going to end up rounding to 900 anyway. So if I then rounded to the nearest 100, well, we already know that I've got 8 in my hundreds and 9 in my tens. If 9's my decider, well, I'm definitely going to be rounding up, and that would also be 900. So no, there is no difference between my two answers. Now, sometimes you will get questions like this, and regardless of what you're rounding to, you may get the same answer more than once because of the numbers that are involved in that particular question. Something to keep in mind. Okay, so well done for going through those questions. Let's now have a look at a real world example. So, you're at the supermarket and you have the following items on your shopping list. We have bread for £1.89, milk for £1.29, eggs for £2.45, apples for £1.79, and bananas for £1.65. Assuming we need everything on the list, estimate the total cost if we bought one of each item. So we need to do some column addition here. Now this is the first time we're going to be looking at an example of column addition involving decimals. The practice is exactly the same as before, but rather than starting at the ones column, we're going to start in the hundredths column. When you're dealing with decimals, it's important to start with the lowest number first and the lowest column, which in this case would be the hundredths. So I'm just writing them out one by one. Okay, so 5, add 5, add 9, add 9, add 9 is 37. So I would put a 7 in my hundredths column. and I would carry my 3 across to the next column. Then I have 8, add 2, which is 10, add 4, which is 14, add 7, which is 21, add 6, which is 27, add the 3 that I had to carry over, and that gives me 30. So far I have 0.07, and I carry over a second 3 into my ones column. So now I have 1, add 1, which is 2, add 2 is 4, add 1 is 5, add 1 is 6, add on the 3 that I carried over. 6 add 3 is 9. So my answer is £9.07. That would be what my total shopping list came to. So part B says, or part 2 rather, you have a £10 note with you. Is this enough to get everything on your list? In this case, yes, £9.07 is less than the £10, so yes, I would have enough. If I chose to buy 2 of an item, I may not have enough money left over. This is a simple example of a real-world problem, and you can see very quickly that these simple mathematic principles come in very handy and will continue to do so throughout your life. Okay, a couple of other real-world questions, this time a bit more wordy, so please feel free to pause the video to take it all in, and then we'll go through them together. So, you're off on holiday. Where you're going is going to be much warmer than home, where the average temperature for the summer is only 16 degrees Celsius. When you get off the plane, it's an intensely hot 37 degrees Celsius. What is the difference between the two temperatures? An interesting question. Now, I haven't left myself much room here for calculation, so I'm going to have to write up here, but that's okay. To work out the answer to this question, the difference in the temperature, I could, of course, draw a number line. That would be absolutely more than fine. I'd have 40 degrees maybe up here and 15 degrees over here, and I'd put the necessary amount of notches in place and I could count accordingly. But my preferred method is to simply start with our hotter temperature, which is 37, and take away the cooler temperature because we're looking for the difference between. Now 37 take away 16 leaves me with 21 degrees difference. So the difference between 37 degrees and 16 degrees is 21 degrees Celsius. That's a serious difference. Okay, and part 2, now it's the winter time, a season which is usually mild at home, but you're visiting family up north. They expect to experience temperatures as low as -9 degrees, much colder than the 8 degrees you're used to. How many degrees colder will it be? Can you represent this difference as a calculation? Well, first of all, I think it's definitely time to employ the number line. We're starting with 8 degrees. And we're going down, I'm going to write -10, but we're only going to go to -9. So 8, 7, 6, 5, 4, 3, 2, 1, 0. So we're already taking away 8. So to get to 0, we've already taken away 8. And then to get to -9 from 0, I need to take away another 9. So I've taken away 8 to get to 0. 8 take away 8 is 0. and then I need to take away another 9 to get to minus 9. So I've taken away an 8 and I've taken away a 9. So to work out how much I've taken away altogether, 8 add 9 is 17. So it's a difference of 17 degrees between -9 and 8 degrees. Now, if you were going to write this as a calculation, you could write it as the following. 8 take away -9 equals 17. Now this might look a bit odd, and we will be going over what a double negative means. But in maths, if we have a double negative, it becomes an add. Now we know that 8 add 9 does indeed equal 17. But when we have a double negative, that becomes an add as well. Do not worry about that too much for now. We will be having a whole lesson on this. But that is how you would represent it in a calculation. Let me write it out once more for you. 8 take away -9 equals 17. As I said, we will be going over this topic in much more detail in a future lesson. Okay, congratulations, you have come to the end of your first lesson of this Level 1 Maths Functional Skills course. I hope you enjoyed it. I hope you learned lots. You're more than welcome to watch any part of this video through again for some clarification. And I encourage you to crack open those books from City and Guild, paying special attention today to pages 2 to 4 for some more examples of what we have looked at today. I look forward to seeing all of you again next week.